So now I'm going to solve the system by the addition method. And remember, in the addition method, your goal is to get opposite coefficients. So if the bottom one has a 2x, I need the top one to have a negative 2x. So I'm going to multiply this whole equation by negative 2. If I do that, I get negative 2x minus 10y is negative 34. And here I have 2x plus 4y is 10. Then when I add them together, the x variables add to 0. And so I get negative 6y equals negative 24. Divide by negative 6, and I get y is 4. And once I know y is 4, I can go to either equation. I'll go to the first one. X plus 5 times 4 is 17. X plus 20 is 17. Subtract 20. X is negative 3. So the solution is y is 4 and x is negative 3. But before I write that as an ordered pair, I'm going to check it in both equations. In the first one, negative 3 plus 5 times 4 equals 17. Negative 3 plus 20 is 17. That is correct. And then 2 times negative 3 plus 4 times 4 is supposed to be 10. Negative 6 plus 16 equals 10, and that is correct. So my solution set is an ordered pair inside of a solution set. And look, they asked me just for the ordered pair. So technically the solution set is what you should write. But they just asked for the ordered pair. So in my math lab, I would write negative 3, because x has to come first, and 4, and you have to put parentheses around it. Now let's try number 17 here by addition. I'm going to multiply. To make these opposites, I need to multiply the first one by negative 2, and I get negative 8x plus 6y, or minus 6y, equals minus 16. And then 8x plus 6y equals 0. And when I add this together, I get 0 equals negative 16. And so that's nonsense. All right? 0 is not equal to negative 16, so there's no solution. This is one of those inconsistent systems. And again, I won't test you on that, but what I want you to know is that if drawn, these are parallel lines. If you were to graph those lines, they would be parallel lines. And I do want you to recognize that these lines would never cross, and that's why they're called parallel.